In a surprising move, Elon Musk revealed on X that Tesla will shift its focus from battery-powered vehicles to hydrogen fuel cells. This decision comes as Tesla faces challenges in mass-producing its 4,680 battery cells, leading the company to search for alternative sustainable energy solutions. Musk also introduced Tesla's water engine, which is expected to play a key role in this transition. This revelation raises several questions. What exactly makes this water engine so groundbreaking? How will it impact the automotive industry and other sectors? Stay tuned for the latest developments in mind-blowing technology from the Tesla CEO. Elon Musk, the visionary leader behind Tesla and SpaceX, is a prominent figure in technology and sustainability. His unwavering dedication to innovation has led to groundbreaking advancements in the automotive and space industries. With Tesla, Musk's vision was not simply to produce electric vehicles, he sought to revolutionize transportation. He has been instrumental in accelerating the shift towards sustainable energy solutions by demonstrating electric cars' superior performance and desirability. Musk's ambitions with SpaceX go beyond Earth, with reports indicating that SpaceX wants to make space travel available for everyone and pave the way for human colonization of Mars. His relentless pursuit of these goals has solidified his reputation as a modern technology pioneer. The water engine is very practical, and the reason why Tesla believes so much in it will blow your mind. Remember that SpaceX's efforts in rocket reusability have also reshaped the space industry. The successful landing and reuse of rockets are now a reality, thanks to SpaceX's engineering prowess. This achievement demonstrates Musk's ability to bring ambitious visions into reality. Nobody believed in Tesla's visions when it started in 2003. At that time, electric vehicles were widely viewed as impractical. However, Musk's persistence led to the creation of the Roadster, a high-performance electric car that defied expectations and demonstrated the potential of electric mobility. He didn't stop there. Tesla introduced the Model S, X, 3, and Y, each of which pushed the boundaries of battery technology, range, and autonomous driving capabilities, making electric vehicles an increasingly attractive option for consumers. Beyond rockets and early Tesla electric car models, Elon Musk has demonstrated a keen interest in sustainable energy through the Tesla Powerwall and solar roof products. Tesla's solar roofs were designed to create a sustainable energy ecosystem for homes and businesses by integrating solar power generation with efficient energy storage. These products offer practical solutions for reducing reliance on fossil fuels. Let's go back to space exploration for a moment. SpaceX has achieved remarkable milestones in space exploration. The Falcon 9 rocket reduces the need for burning through raw materials in rocket production, and the Starlink satellite constellation aims to provide global internet coverage. These achievements showcase Musk's far-reaching impact on technology and innovation. Now, let's talk about the water engine. This technology operates on a simple yet innovative principle, using water to generate energy. Things are about to get a lot more interesting. Traditional combustion engines rely on fossil fuels, while electric models run on batteries. Neither of these options can provide the level of clean energy the world needs. The water engine employs a process known as reverse electrolysis. To break it down, ordinary electrolysis uses electricity to break water into hydrogen and oxygen, while reverse electrolysis does the opposite. It combines hydrogen and oxygen to create electricity, with water vapor as the only byproduct. This makes it a clean and eco-friendly energy source. Here, water is added to the system, and an initial energy input splits it into hydrogen and oxygen. These are stored in separate tanks inside the vehicle. When the engine runs, hydrogen flows into a fuel cell. Inside the cell, hydrogen is split into protons and electrons. The electrons create an electric current to power the motor, while the protons combine with oxygen to form water vapor. This process is a loop. Water becomes energy and then turns back into water. It's a game changer for creating sustainable and environmentally friendly energy. Inside the fuel cell, protons move through a special membrane and combine with oxygen from the air to produce water vapor. As long as hydrogen and oxygen are provided, this process keeps generating electricity efficiently. But how does this water-powered engine compare to regular and electric engines? The results are mind-blowing. Keep watching to find the answer and many more. Elon Musk's electric engine versus a water engine, according to experts, traditional combustion engines are about 20 to 30% efficient, wasting much energy in the form of heat. On the other hand, electric engines are much better, with an efficiency of 85 to 90%. But sadly, electric engines also have their downsides. For instance, they are slow to charge, and eventually, the battery wears out over time. The water engine is in the middle, with around 60% efficiency. While its efficiency is not as high as that of electric engines, it has another huge benefit: it is much cleaner and more sustainable. This makes it a promising alternative for greener energy in the future. And that's not all. The water engine uses the high energy in hydrogen to go as far or farther than traditional gas-powered cars. Think about a car that only gives off water vapor and doesn't leave you worried about running out of power on the road. That's what makes the water engine so interesting. Unlike electric cars that need long charging times, the water engine can be refueled quickly, just like a gas car. This speed and its eco-friendly nature make it a strong option for transforming the automotive industry. One of the biggest advantages of this is cutting down carbon emissions. Regular engines release a lot of carbon dioxide and pollutants, which harm the environment and contribute to climate change. The water engine, on the other hand, produces only water vapor. It's a clean, sustainable option that could help reduce our carbon footprint and lead us towards a greener future. To put it into perspective, a typical gas-powered car pumps out about 4.6 metric tons of carbon dioxide yearly. Switching to water engines could completely erase these emissions. Additionally, environmental activists believe that urban air quality would improve dramatically without nitrogen oxides and other harmful particles. Electric vehicles are cleaner than gas cars, but they are not perfect. Mining for battery materials like lithium and cobalt harms the environment. If the electricity for charging an EV comes from fossil fuels, the carbon savings aren't as big as they claim. The next clean option is hydrogen fuel cells, since they only produce water as waste. But it's not as simple as it sounds. The production of hydrogen often relies on natural gas, which still releases carbon. This shows how tricky it can be to find truly sustainable ways to power transportation. The water engine offers a promising step toward a cleaner and greener future. Storing and transporting hydrogen is relatively easy, but it has low energy density and requires high-pressure tanks to keep it stable. However, what Tesla engineers have done to solve these challenges is truly remarkable. They believe that by using reverse electrolysis, their water engine could address these issues in a cleaner and more efficient way. In addition to the technological benefits, there is another important factor to consider: finance. Financially, the water engine could result in significant long-term savings. Gas engines require regular maintenance, such as oil changes and exhaust repairs, which can add up over time. Electric cars, with fewer moving parts, cost less to maintain, but battery replacements are expensive and can also have an environmental impact. With its simpler build and fewer components, the water engine requires less upkeep and has lower running costs. These savings could make it a more affordable option for consumers, and it could be a cleaner, cost-effective alternative to traditional gas-powered and electric vehicles. The components of water engines, like fuel cells and electrolysis systems, designed to last, potentially giving vehicles a longer lifespan. As technology improves and becomes more widely produced, the initial price of water engine cars could decrease, making them more affordable for a broader range of people. However, switching to water engines is not without its challenges. For starters, Tesla would need to make a significant upfront investment to establish refueling stations. New infrastructure may need to be built or existing stations upgraded to accommodate water refueling technology. This will require collaboration between governments and private companies to create a global network. If implemented successfully, water engines could reduce our reliance on oil, leading to more stable fuel prices and easing tensions related to oil supply issues. The shift to sustainable energy could have far-reaching positive effects on the global economy, including job creation in industries focused on water engine technology, manufacturing, and infrastructure development. Another major challenge Tesla faces is overcoming resistance to change within the automotive industry. The current infrastructure is deeply embedded in fossil fuels, from manufacturing processes to refueling networks. Many stakeholders in the traditional sector may resist the transition to water engines. To address this, Tesla could leverage existing technologies and expertise. For example, principles of hydrogen fuel cell technology, such as design and storage, can be applied to water engines, potentially accelerating development and deployment. So, what does the future hold for Musk's water engine? Will it revolutionize energy and transportation, or will it falter in the face of these challenges? The automotive industry is watching closely, and many recognize the potential disruption this technology could cause. To ensure widespread adoption, Tesla will need to focus on developing efficient, cost-effective reverse electrolysis systems, creating a reliable water refueling infrastructure, and ensuring the safety and reliability of the technology. If these challenges are addressed, the water engine could revolutionize the automotive industry and pave the way for a cleaner, more sustainable future. You may be surprised at the reaction of key major players to Elon Musk's announcement. Major players in the automotive industry, such as Toyota and Hyundai, who have long championed hydrogen fuel cell technology, have expressed mixed reactions to Musk's venture. According to industry experts, Toyota views Musk's endeavor as a validation of its long-held belief in the potential of hydrogen. They see it as a positive step toward wider acceptance and investment in hydrogen infrastructure, having made significant investments in hydrogen engine research. On the other hand, Hyundai has taken a more conservative stance on hydrogen engine research. Media reports suggest that Hyundai is not ready to invest much in the development needed to support hydrogen and water engine technologies. Are you still doubting the feasibility of the water engine? Well, you are not alone. Even seasoned industry experts are not on the same page about this. While some hail it as a groundbreaking move that could accelerate the shift to sustainable energy, others express skepticism about the real-world applications. According to Joseph Ra, a former U.S. Department of Energy official, hydrogen cars are among the least efficient and most expensive ways to reduce greenhouse gas emissions. That is not all. Ra also argued that the infrastructure costs for a nationwide network of hydrogen refueling stations would be too expensive for any person or government to bear. Additionally, over 100 scientists, led by Professor David Shawn of the University of Cambridge, criticized using hydrogen-powered vehicles for the Paris 2024 Olympics. They argued that these vehicles are not as environmentally friendly as claimed, pointing out that hydrogen cars require approximately 3 times more renewable electricity than battery electric vehicles. They also noted that most hydrogen is produced from fossil fuels, undermining its green credentials. Maybe Tesla's water-powered engine will address some of the fears raised by these critics. No matter what the experts say, the ultimate say lies with the public, who are expected to be the products and users. So, how exactly has the public reacted to Elon Musk's water engine aspirations? Elon Musk's announcement about the water engine was met with excitement, curiosity, and doubt. Tesla fans and environmentalists have eagerly shared the potential for cleaner, more efficient engines on social media. Many are excited about the prospect of reduced emissions and the chance to redefine sustainable transportation, but not everyone is convinced. Remember that Elon Musk had always dismissed the idea of a water engine, and people are now wondering why he suddenly shifted from his previous skepticism of hydrogen technology. But there is another disturbing reality, and you will need to keep watching to find out. One of the biggest concerns is building an entirely new refueling infrastructure. While gas stations are everywhere and electric vehicle charging networks are growing quickly, creating a similar system for water engines would demand significant funding and collaboration. The success of this technology depends on tackling some big hurdles. First, reverse electrolysis must become more efficient and affordable. Second, a widespread, user-friendly refueling network needs to be built. Lastly, winning over the public will require addressing fears about costs, safety, and practicality. If Musk and his team can overcome these obstacles, the water engine could revolutionize transportation and pave the way for a greener future. This journey won't be easy as it is full of many unknowns. Only time will tell if this bold vision becomes a reality. In contrast to the widespread network of gas stations and the rapidly expanding infrastructure for electric vehicle charging, the infrastructure for hydrogen fuel cells remains in its early stages. Hydrogen refueling stations are still relatively scarce globally, concentrated primarily in regions like California, Japan, and parts of Europe. While this network offers a foundation for water engines that use a similar hydrogen-based refueling process, significant expansion is necessary to support widespread adoption. The good news is that Tesla has a plan. According to company sources, Tesla will leverage its expertise to build EV supercharging stations. The company plans to retrofit existing EV stations with hydrogen refueling capabilities and construct new stations specifically designed for water engines. This ambitious undertaking requires substantial investment and collaboration with governments and private sector partners to ensure widespread availability and convenience for consumers. However, key questions remain about the speed at which this network can be built and the logistical and financial obstacles that must be overcome. These questions are crucial as Tesla progresses with its water engine rollout. The cost of infrastructure development, the reliable production and distribution of hydrogen, compliance with safety regulations, and public perception pose significant challenges that must be addressed for successful integration of this new technology. Safety is undeniably paramount when introducing new technology, and the water engine is no exception. We are about to reveal a critical flaw in the water engine concept that you don't want to miss. While hydrogen offers a clean energy source, it is highly flammable and requires careful handling. Remember that the water engine converts water into hydrogen, essentially inheriting these safety challenges. To mitigate potential risks, Tesla has implemented several safety measures. For instance, they will integrate an advanced hydrogen storage system to ensure hydrogen is stored securely within the vehicle. These systems are designed to withstand high pressure and prevent leaks, undergoing rigorous testing procedures to meet and exceed safety standards set by international regulatory bodies. By prioritizing safety at every stage of development and deployment, Tesla aims to establish the water engine as a reliable and secure technology. However, whether these safety measures will fully alleviate public concerns remains to be seen. Building trust and ensuring public confidence will require ongoing communication and transparency about the technology's safety features and protocols. Additional steps, such as public awareness campaigns and independent safety certifications, could further enhance the perception of the water engine as a safe and trustworthy alternative. This brings us to the issue of legal and regulatory requirements. Regulations regarding hydrogen storage, transportation, and use differ from country to country. Tesla will need to work closely with regulatory bodies to ensure compliance and secure the necessary approvals for widespread adoption of this new technology. The problem is that this process is not as simple as it seems. It often begins with extensive documentation, rigorous testing, and ongoing dialogue with regulators to address concerns and adapt to evolving requirements. Without these efforts, Tesla would never have overcome regulatory hurdles. Another important question to answer is whether it's worth the stress. This is the case for the water engine. Let us begin by examining how the water engine compares to hydrogen fuel cells. As we mentioned earlier, hydrogen fuel cells offer high energy density, which allows for long driving ranges and quick refueling times. Additionally, they only emit water vapor, making them environmentally friendly. However, challenges arise in producing, storing, and transporting hydrogen gas, which is highly flammable and requires specialized infrastructure. Water engines, on the other hand, excel in on-demand hydrogen production. This means they can offer better storage solutions and reduce the risks associated with handling hydrogen gas. But there is more to water engines. They can seamlessly integrate with renewable energy sources, further enhancing their sustainability. However, reverse electrolysis, which is crucial for their operation, requires a significant initial energy input, potentially affecting their overall efficiency. In conclusion, the success of water engines will depend on various factors, including overcoming technical challenges, developing robust refueling infrastructure, and competing with existing technologies such as hydrogen fuel cells and battery electric vehicles. We've already discussed the high costs of research, development, and investment necessary for water-powered vehicles. Now, you may be curious about Tesla's earning potential and that of potential investors. The market potential for water engines seems promising, though not without its challenges. The automotive industry is shifting its focus toward reducing carbon emissions and adopting sustainable energy sources. Governments around the world are implementing strict emissions targets and offering incentives for clean energy technologies, thus creating a favorable environment for innovations like the water engine. Innovators such as Elon Musk are not alone in their commitment to sustainability. Regarding market potential, water engines may initially appeal to early adopters and environmentally conscious consumers. However, as the technology improves and costs decrease, adoption is expected to increase. According to forecasts from analysts, water engines could capture substantial market share in the next decade. If Tesla can address the efficiency issues and develop the necessary infrastructure while scaling up manufacturing, there is great potential for growth. Tesla may also need to partner with both the public and commercial sectors to ensure this growth. It is crucial to note that water engines will not dominate the market alone. The technology will still have to compete with established systems like battery electric vehicles and hydrogen fuel cells. Each of these technologies has its own strengths and weaknesses, and factors such as cost, range, refueling time, and environmental impact will shape consumer preferences. Beyond Elon Musk's determination and the ingenuity of Tesla engineers, other factors such as government policies, technological advancements, and consumer demands will play a significant role in the market fortunes of water engines. There is something unsettling about these factors, though they are not constant. Water engines must be adaptable and evolve in order to remain competitive in this dynamic environment. Ultimately, the success of water engines will hinge on a combination of technological innovation, strategic partnerships, and favorable policy conditions. If these elements align, water engines could disrupt the automotive industry and contribute significantly to a cleaner, more sustainable future. Now, let's take a brief walk down memory lane for those who remain skeptical about this technology. What we will reveal will completely change your mind about water engines. The journey of engine technology began centuries ago with the invention of the steam engine in the late 17th century. Pioneers like Thomas Newcomen and James Watt significantly improved these early designs, revolutionizing transportation and industry. Steam engines became the driving force behind the Industrial Revolution, powering locomotives, ships, and factories. However, the late 19th century witnessed the emergence of the internal combustion engine, thanks to the ingenuity of inventors like Nikolaus Otto and Rudolf Diesel. Otto's four-stroke engine and Diesel's compression ignition engine laid the foundation for modern gasoline and diesel engines. These engines offered greater efficiency and power, leading to widespread adoption in automobiles, aircraft, and ships. The 20th century saw further refinements in internal combustion engines, with advancements in materials, fuel injection systems, and turbocharging. These improvements enhanced performance, fuel efficiency, and emissions control, making internal combustion engines the crown jewel of modern transportation. However, concerns about pollution and fossil fuel depletion grew, and the search for alternative fuel engines intensified. This brings us to the late 20th and early 21st centuries, when electric vehicles began to gain traction. They promised a cleaner and more sustainable alternative to traditional combustion engines. This shift toward electric mobility marked a new chapter in the ongoing evolution of engine technology, driven by the need for a cleaner and more sustainable future. Companies like Tesla, under Musk's leadership, spearheaded the EV revolution, with advancements in battery technology, range, and charging infrastructure. However, the call for alternative fuel engines came earlier than Musk's recent efforts. Do you remember that hydrogen fuel cells were developed in the 1960s? NASA used hydrogen fuel cells to power spacecraft during the Apollo missions, demonstrating the potential of the technology. However, we could not achieve adoption on a commercial scale due to several problems. For instance, the cost of hydrogen production, storage, and infrastructure was too high. Another commendable attempt was the development of biofuel engines in the early 2000s. There was a surge of interest in biofuels like ethanol and biodiesel, derived from plants and organic waste. While biofuels offered a renewable energy source, they also faced limitations. Producing a small quantity of biofuels required vast amounts of agricultural land and water, raising concerns about food security and environmental sustainability. Electric vehicles themselves represent a major shift in engine technology. Early EVs, such as General Motors EV1 in the 1990s, showcased the potential of electric propulsion. However, limited range, high costs, and inadequate charging infrastructure hindered widespread adoption. It wasn't until advancements in lithium-ion batteries and the establishment of extensive charging networks that EVs began to thrive. One key lesson from the history of alternative fuel engines is the crucial role of infrastructure. Both hydrogen fuel cells and early EVs face significant challenges due to the lack of adequate infrastructure. Musk's plan to leverage Tesla's existing supercharger network for hydrogen refueling will address this barrier head-on. Despite being renewable, biofuels often consume more energy during production than they yield. Musk aims to maximize energy efficiency by optimizing the reverse electrolysis process in the water engine, ensuring that splitting water and recombining hydrogen and oxygen is as efficient as possible. In this historical context, Musk's water engine represents the latest evolution in the quest for cleaner, more sustainable engine technology. By building on the successes and learning from the challenges of past innovations, Musk is pushing the boundaries again. He's attempting to address the limitations of previous alternative fuel technologies while capitalizing on the existing infrastructure and expertise developed for electric vehicles. If you believe Elon Musk's interest in water engines is not feasible, you should take a closer look at the evolution of engine technology. Remember the old saying, necessity is the mother of invention. With that in mind, we should also consider where we go from here. What does the future hold for water engine technology, and who are the key players to watch? Apart from Tesla, the most intriguing part of this discussion lies ahead. You won't want to miss it. The future of water engine technology is a topic of great promise, especially with Tesla's water engine making waves. However, several companies and innovations could emerge as serious competitors in the sustainable transportation space. For instance, the Nikola Corporation specializes in hydrogen-powered trucks, presenting a potential rival to Tesla. Despite setbacks, Nikola has made significant strides in developing heavy-duty vehicles that run on hydrogen fuel cells. Their focus on the commercial market, especially long-haul trucking, could pose a real challenge to Tesla in this sector. BMW, with its strong brand reputation and engineering expertise, is also delving into water engine technology. The company has been exploring hydrogen fuel cell technology, unveiling prototypes and committing to further research. BMW's entry into this market could heighten competition, particularly in the luxury vehicle segment. Another key player that stands to have a significant stake in this development is Rivian. This electric vehicle startup, backed by major investors like Amazon and Ford, is currently focused on battery electric vehicles. However, Rivian's innovative approach and substantial funding could allow it to shift toward water engine technology if market demand pivots in that direction. Collaboration will be crucial for the rapid development and widespread adoption of water engines. Tesla has a history of forming strategic partnerships to advance its technological goals, and such collaborations could speed up innovation, enhance infrastructure development, and drive down costs. These benefits would ultimately serve both the industry and consumers. To stay ahead of its competitors, Tesla will need to leverage its technological prowess, form strategic alliances, and adapt to evolving market demands. Partnerships with leading tech companies, universities, and research institutions could give Tesla access to cutting-edge research, specialized knowledge, and advanced technologies, accelerating the development of its water engine. For example, collaborations with universities at the forefront of hydrogen research could help improve the efficiency and performance of Tesla's water engine. Partnerships with materials science departments could lead to the creation of more durable and efficient electrolysis systems. Moreover, working with experts in hydrogen storage and transportation could yield safer and more compact storage solutions. Additionally, alliances with tech giants such as Google or Apple could enable the integration of advanced software and AI capabilities into water engine vehicles. In order to achieve true environmental sustainability, the hydrogen used in water engines can be produced through electrolysis powered by renewable energy sources like solar or wind power. Imagine homes equipped with solar panels that generate hydrogen fuel during the day, which is then used to power water engine vehicles. However, the applications for water engines go far beyond just automobiles. According to insiders, Tesla is exploring the use of this technology in the aviation sector. Ships powered by water engines could significantly reduce the environmental impact of global shipping, contributing to cleaner oceans and air. This is especially important given the significant contribution of the shipping industry to global greenhouse gas emissions. Water engines could also provide a sustainable alternative for industries with high energy demands, such as heavy industries. By reducing reliance on fossil fuels and cutting emissions, water engines could revolutionize sectors like manufacturing, mining, and construction, helping them transition to cleaner energy sources. Ultimately, the potential of water engines goes beyond just transportation. They could transform power generation and industrial processes, playing a significant role in creating a greener and more sustainable future. Thank you for staying with us. Do you think the water engine will be the future of clean energy transportation? We'd love to hear your thoughts in the comment section. If you enjoyed the video, please like, share, and subscribe to our channel. Be sure to click on the next video on your screen. You're sure to enjoy it.